Hi everyone. Today we're going to have Dr. Fernando with us, and in the newest version of the IYCN Science Café, you're going to talk with us about how the new top 10 emerging technologies are selected. So at first, I would like to give you a brief introduction about myself. My name is Hiba. I am the IYCN Conference Presence Committee co-chair together with Tracy Rowe, and we have our newest member, Elsa Brass. Maybe you can present yourself.
Hello everyone, my name is Elisa. I am a member of the Conference Presence Committee of the IYCN, and I am very glad to co-organize this event. And I also want to take this opportunity to thank Dr. Fernando Gomollón-Bel for accepting the invitation, and also the audience for joining us in this Science Cafe. And now I hand over to my colleague, Walid.
So our Science Cafe schedule will be as following. We will first have a first minute talking about an introduction about ourselves, the IYCN, and then a brief introduction about our speaker, Dr. Fernando. Then followed by a 30 minutes presentation, followed by a Q&A session and closing remarks. So first, I'm going to give you a small introduction about ourselves. So we are the International Younger Chemists Network. We are an associated organization of the IUPAC since 2017. We have a vision of connecting and empowering younger chemists globally, and our mission is to support and advocate these scientists across all chemical sciences to achieve a globally sustainable future. So this is our photo during the IYCN General Assembly in Paris 2019. For those interested to join our committee or to join the IYCN in general, you can follow the membership form link. You can open our website and apply. It's for free. Also, if you want to connect with us and also see our newest projects and our newest sessions, please follow us on social media platforms, including LinkedIn, Facebook, Twitter, and Instagram. So without further ado, let me introduce our speaker for this Science Cafe, Dr. Fernando Gomollón-Bel, co-founder of Agata Communication Limited in UK. So Dr. Fernando is specialized in science writing and science communication. He worked in the Institute of Chemical Research of Catalonia and the University of Cambridge. He also co-founded Agata, if I spell it correctly, Communication, a small startup which is dedicated in making the complicated easy. He also writes publications for multiple journals from Chemistry World and the notorious Chemical and Chemical Engineering News, CNN. He also recently published an article with the IUPAC president, Professor Javier Garcia Martinez. So I would like to congratulate him for his newest article. And without further ado, Dr. Fernando, the floor is yours.
Thank you very much. Okay, hopefully you can all see me and listen to me now. Thank you for the invitation, and thank you for the very kind introduction. I hope to be able to share the screen and start this conversation, which is going to be about the IUPAC Top 10 Emerging Technologies. So like I said, this is going to be a brief presentation. I mean, you did say 30 minutes. It may be a bit shorter, I don't know, about the IUPAC Top 10 Emerging Technologies in Chemistry. And we're going to look into the past, the present, and hopefully the future of this initiative, which is an initiative that is coordinated and launched by IUPAC. And just as a disclaimer, conflict of interest, whatever at the beginning, so you understand a little bit more what my role is in the IUPAC Top 10. IUPAC, I work for IUPAC to write the annual article about the top 10. So IUPAC pays me to use my science writing skills to talk about the technologies that they consider more trending in chemistry. So that's the little conflict of interest here. So I'm not the coordinator of the initiative or anything like that, but I'm very happy that I get to be here to talk about the initiative, about what we've done so far, and about what we have in the pipeline for the future. So first off, I always like to start the presentation with like a little thank you to the organizers. I have a very, very close connection, a very dear connection with IYCN, with the International Younger Chemists Network. And it's a true pleasure to be in these cafes, and we will talk a little bit more about IYCN further down the line. But before that, thank you so much for the invitation. It's been a great pleasure to join this event, and I hope that you enjoy it now. And if it's recorded, which I think it is, hope that we will enjoy it in the future as well. So first of, like I said, I wanted to go back to the past of the initiative and how it originated and how it started. So for that, we need to go back to 2019, and this year marks two important occasions in the world of chemistry. First, it was the 100th anniversary of the foundation IUPAC in 1999. And then it was also the International Year of the Periodic Table. So that, I think, marked 150 years of the birth or the death of Mendeleev. I can't remember now. But anyway, so it was like the 150th anniversary. So that marked also the International Year of the Periodic Table. So because of these two occasions, IUPAC, for like those of you who don't know, it's the International Union of Pure and Applied Chemistry, but I'm assuming that people from IYCN know IUPAC already. So basically, IUPAC decided to celebrate their own anniversary and the International Year of the Periodic Table, creating a new initiative, which was called the IUPAC Top 10 Emerging Technologies in Chemistry, which basically was designed to celebrate chemistry and highlight the importance of chemistry in our everyday life and highlight the importance of chemical technologies in a path to a brighter and greener future. So basically, what the IUPAC Top 10 technologies were designed for were to analyze and sort of what's the word, like identify chemical landmarks that are interesting, because I mean, chemical landmarks eventually are sort of everywhere. You can find them in many other places because sort of, I mean, a lot of people say that chemistry is the central science that connects the physical disciplines, and although this has been debated and even refuted by some people, I think it's really cool to actually see that if you analyze all of the different publications and all of the different areas of science, including social sciences and the humanities, chemistry has a very special place. You can debate whether that's the center or not, because it clearly lacks some connections with some fields, but it is way more central than others, connecting physics with things like medical treatment, health, brain research, geology even. So it's really interesting how chemistry connects with all these fields. And because of that, you can find chemical landmarks in many of these sciences and many of these fields. So it's complicated to identify the top 10, but that is what IUPAC decided to do in 2019, and decided to identify discoveries in chemistry and the related fields. So also, identify discoveries in related fields like materials science, chemical engineering, things like that, that had a true potential to change the world. And in 2019, they decided to start with 10. And of course, that's been growing since, and we've selected 10 each year going back to 2019. And some of them, as we will see later, have been proven quite successful, either in the form of commercial successes like RNA vaccines, or in the form of like having received very prestigious awards like the Nobel Prize. So again, because of the chemistry interconnecting the science thing, it's quite a challenge to identify discoveries that will actually have an impact in the world, because like you need to define something a little bit closer and smaller to make sure that you cannot just pick any technology from any paper, from any idea that gets published or patented, because there's many cool things happening in chemistry every day, as we can see in the news and the specialist magazines and the peer-reviewed journals. So you need to really identify the ones that have sort of potential to change the world. And that's why IUPAC calls the top 10 emerging technologies, because it's actually about that word, the emerging technologies, that this is all about. And in 2019, in the first selection, IUPAC also worked in a definition of emerging technology. You know that IUPAC loves definitions, loves nomenclature, and this is one of the things they came up with. They decided to define an emerging technology as an advanced technology that kind of hovers between the eureka moment in the lab and industrial applications. So it's more often than not something that has been already discovered and developed a little bit, and it's ready to go to the market, but it's not fully developed yet. So of course, you're going to find technologies that are a little bit more embryonic and more in the beginning of development, and you're going to find technologies that are almost ready to like find full development, like RNA vaccines, which now have, you know, basically gone to every single country in the world. But like the idea was to find this equilibrium and things that were a little bit in between, to basically highlight them and make sure that industry, educators, science writers, journalists, people working in other fields actually noticed what was trendy and what was interesting, but hadn't been developed fully yet. So that was the idea behind all this. So how it works is basically there's an open call that runs for around 3 months between January and March. And this is open to everybody. I mean, everybody who wants to submit ideas are welcome. There's an online form that is free to fill out. And then people submit the title of the idea, a little abstract, and maybe some references to demonstrate how that technology fits the call and fits the idea of an emerging technology. And then all of that goes, all of the submitted technologies, which could be, I don't know, in the 30s, 40, 50 technologies, go to a committee of IUPAC experts. By the way, the numbers I just made up because I don't know how many get submitted. I just get the selection to write the article about. But anyway, so from the pool of technologies that have been submitted, there's a group of IUPAC experts which are named in every article we publish about the top 10. So it's not secret, it's not closed, it's not a close club of people selecting. It's actually a very international and diverse group of people from industry, academia, and many different countries that select the best technologies and the top 10 every year. And then basically they give that list to me, and they also give me all the references that people have submitted and things like that. And from that, I review the literature and we put together a article that gets published in Chemistry International and a little bit of a social media campaign that helps promote the technologies in social media and among the general public. So this is what we do and how it works. And, you know, as an example, these are the technologies that were awarded, let's say, last year in 2022. So you had sodium batteries, which of course have not been fully developed on industrial scales. You've got nanoscience, aerogels, fluorescent sensors, solar fuels, nanoparticle mega libraries, fiber-based batteries, textile displays, rational vaccines with SMA, and VR-enabled modeling. I mean, of course, some of them have already like some commercial solutions. Like if you go to VR-enabled modeling, there's many pieces of software that allow to do chemical modeling using VR. I think recently I got a press release from one of the companies that does things like that. And of course, like aerogels have been going on for like probably 30, 40 years. But the thing is like, okay, have they actually attained the full commercial potential that they have? And maybe they haven't. So this is the opportunity for people that work in chemistry to see them highlighted and see what's the science beyond what's the science behind the the hype and behind the headlines, and actually have a review of what happens and what's behind all these technologies and why they hold that big of a potential. So since 2019, we've had 4 editions of the IUPAC Top 10 emerging technologies in chemistry. Each of them has selected a list of different technologies, which we will discuss in the next slides maybe a little bit. But this is good because it represents that basically in 4 years it has not stopped, and it will keep going for 2023. Actually, I already know the list, but I'm not allowed to say. So it will keep going in 2023, and hopefully in October-ish, there will be an article in Chemistry International announcing the technologies for this year, and then you can see why they have been selected. There's a lot of very interesting things coming up. So on top of finding these sort of solutions to change the world, which sounds a bit too, maybe over optimistic and maybe a little bit, complicated. Basically, what IUPAC tries to do is to highlight technologies with potential to improve our quality of life, to contribute to our economy, and to advance our society to something that's more sustainable. If you go 2 slides back, you would see solar fuels. So basically, the idea behind solar fuels is to create fuels from sunlight and CO2 to, at the same time, reduce the amount of carbon dioxide in the atmosphere and make fuels that are kind of net zero and carbon neutral. So this is one of the ideas behind the technologies. They need to also promote sustainability. And one way that we look into sustainability is looking at the relationships between the top 10 technologies and the Sustainable Development Goals, which are promoted by the United Nations. So as it was mentioned at the beginning, in a very recent article in Angevante, IUPAC President Javier Garcia Martinez and I, we created this little graph, which basically, the bigger the size of the sector, the more represented an SDG is in the top 10 technologies. So we went technology by technology since 2019, looking at which technologies help which of the Sustainable Development Goals, and then we basically did this graph. Of course, you see that some of them may have been overrepresented, like you see a lot of technologies for health and a lot of technologies for industry, climate, clean water, and not that many for education, not that many for equality. But we're working on that, and we're working to make sure that the sectors that have not been well represented get a little bit more support. And then also we try to ensure, sometimes, industry, energy are obviously going to be overrepresented because chemistry is very linked to those topics, but we're going to try to make them a little bit more diverse, and this kind of gave us a very good map of what has been done so far. So we try to find the links, and we try to understand in which fields of the Sustainable Development Goals chemistry can actually help more to make things a little bit better, a little bit more sustainable, and basically go towards like a net zero carbon-free economy in the future. So that's one of the biggest goals that we have. And of course, like I said in the past, we are very proud that we sort of had some very good predictions, so to speak. So already in 2019, one of the technologies selected in the top 10 was an anti-selective organocatalysis, and that just very recently got the Nobel Prize in 2021 with Ben List and Dave McMillan winning the Nobel Prize for precisely the discovery of an anti-selective organocatalysis. In 2020 already, IUPAC identified AI applied to chemistry as a very interesting tool and one of the top 10 technologies. And today we've got, DeepMind and Meta working in protein simulation and papers coming in AI and chemistry every single day. If you go to our chemistry world, for example, there's a full special issue on AI and chemistry very recently. So it's something that we can call a sort of a prediction, and a prediction that has actually worked. So we're very happy to see the technologies then, either expanding to commercial realities or being represented in awards and things like that. And talking about commercial realities, one that we're very happy to see is like the 2021 top 10, which was sustainable ammonia production. Like, you know, most ammonia today is produced using the Haber-Bosch process, which is not only very inefficient in terms of yield, but also it consumes a lot of energy, it's very energy demanding. So one of the technologies highlighted in the top 10 was the production of ammonia with electrocatalysis and other technologies that make ammonia more sustainable, especially if you use sources of electricity that are sustainable and renewable, like windmills and solar farms. So today, there's mega plants making ammonia in this way in at least 3 continents. So I think this is very nice to see that actually when we highlighted the technology, it was already sort of hovering between the lab and the application. But now you see the applications, and I think this is the idea behind the top 10 technologies, is to highlight technologies so that industry innovators can get new ideas and can get new kind of guidelines on how the research is going, so they can actually deploy new solutions that work based on research that is sound and interesting. So what about the future? Because we did say at the beginning that it was all about the past. So the establishment of the initiative in 2019, the present, which we've been through, and the future. So I think the future holds a lot of very interesting ideas. So first off, we would very much like to find new partners, industrial partners, all the type of partners, like academic partners. Already in 2022, we partnered with FEICE, which is the industry association, the chemical industry association in Spain. And we also partnered with the International Year of the Sciences for Sustainable Development to give a little bit of a boost to the initiative. So we are actually actively seeking partners to make this a little bit bigger. We want to make an impact in education. So we want this resource of like the features published in Chemistry International and the actual initiative, only the top 10, the videos, everything we release, to be useful as an educational tool because it really highlights the value of chemistry beyond what we normally learn in school about Lavoisier and Marie Curie and whatever. It actually talks about real chemistry that can actually change the world. So this is really, really interesting. And we also want to look into more chemical education technologies and ideas, because so far I think we've only highlighted the VR-enabled models and we haven't actually talked about anything else. But it's going to become increasingly important, especially in the times of generative AI, like ChatGPT, things like that. We're going to need to talk more about how we address education and education in chemistry. And then especially after COVID, we're going to have to talk about how we address remote education, because I think it's something that's going to stay on for a while, and we need to talk about that. And then eventually, this is like a dream of mine, but it's also, I'm assuming, a very good idea of what a IUPAC does. It's to use this initiative to serve and to contribute to policy advice, not only to inspire innovators in industry, but also to inspire policymakers to either like promote the public funding of technologies that have great potential, but also to promote new legislation and to prepare new legislation that anticipates the change and anticipates the novelties in chemistry and chemical engineering and material sciences. So I've got a few slides about IYCN because I think you can really do a lot. I mean, you already have the Science Café, which had Javier Garcia talking about this already, and you had Professor Abdullah Aili and Yalinu Poya talking about the two of the technologies, the chemical synthesis of RNA and DNA, and the sustainable production of ammonia, which we have already talked today. And you have me today, so you're already doing a lot to promote this beyond the usual scope of the top 10 technologies. But I mean, try to keep doing this because it's a great thing. But then also don't stop there. Like I said, IUPAC counts on a pool of experts to judge the technologies, but we also need the submission of technologies every year. So for both things, volunteer by all means. Like if you volunteer as an expert to judge the technologies, and if you submit your own technologies, that is something that can really benefit the initiative to have a longer life. And then, like I said, we want to have a bigger educational impact. So you can either help with that with the webinars that you organize, but also supporting every opportunity that we have and everything that we do, and maybe even like helping with things like translations or like dissemination of the content we release as part of the social media campaign and things like that. So help out disseminate the initiative, because you can really contribute to this. And then like I said, like spread the word. There's many articles published already. We've got 4 about the 4 different selections from 2019 to 2022, all published in Chemistry International. And then, like it was mentioned at the beginning, we just published an Angevante paper, but also last year Nature Chemistry comment editorial about this initiative. And I think it's important to talk about them, to help disseminate what they do. And in our effort to make this idea and this initiative as visible as possible, we have actually made all of this, the Chemistry International article, the Nature Chemistry, and the Angevante editorial, all of them are open access. So you can actually download them for free, read them for free on HTML. It's super easy to access them. And we want this because it's part of the idea that, I mean, otherwise we wouldn't reach industry innovators, we wouldn't reach policymakers, we wouldn't reach education leaders. So I think it's important to share all the knowledge that we have in open access. And I think in the slides before, you basically have the DOIs for all of the articles, and they're all clickable. So I will share the slides after this in case you want it, but I mean, it's not hard to find. If you Google my name or Javier in like Google Scholar or whatever, it's easy to find these articles. And then, of course, if you want to learn more, please, by all means, come to the next conference that IUPAC is organizing in the Netherlands. It's going to take place in The Hague from the 18th to the 25th of August this year. I'm going to be there for several reasons, but one of them is to talk about the top 10 and to promote what we do in IUPAC to support this initiative. And of course, please also connect with IUPAC, not only through IYCN, but there's also many other channels on social media. They have their affiliate members, they have the supporters, they have many initiatives like the Global Women's Breakfast. Everything that you do to disseminate the things that IUPAC actually does, I think is really, really helpful. And then also IYCN, as the sort of younger division of IUPAC, has a great potential to become like new blood, so to speak, in the running of IUPAC. So it's something that we really need in the chemical community, to have a more diverse, younger, people basically running things and motivating the new initiatives, not only the top 10, but also new ideas that come along, like these science cafes. So please connect with IUPAC and collaborate with them as much as you can. And I think I've actually sort of have an hour sharp-ish. But I'm gonna just finish by thanking you again and leaving the floor open to questions. If there's any, I'm sure there's a chat somewhere, and I'm sure you can send them. And also, I mean, again, I'm on Twitter, email, many other places, LinkedIn. So if you want to connect with me personally, or if you need access to any of the manuscripts, even though they're open access, but if you need the PDF for whatever reason, drop me a line and I'm super happy to share them with you. And if you want to collaborate with the top 10 in any way, also reach out, because it'd be great to grow the family and make this a little bit like a smoother work in the future. So yeah, by all means, do get in touch and connect. And again, thank you IYCN and everybody in the organizing committee for inviting me. I really look forward to the questions, and I really look forward to meeting you in person in The Hague if you're attending the conference. If you see me there, don't just go reach out and say hi. I'll be very happy to chat with you. I'm gonna try to see how I can unshare this, and then we can go into the questions. Thank you so much.
Thank you very much, Dr. Gomollón-Bel, for your wonderful presentation. We are now going to move to the question sessions of the Science Café. And the first question is, what challenges have you experienced when trying to communicate about these top 10 technologies?
Yeah, that's a very good question. So I think actually the biggest challenge is to find a way to, like you said, to communicate about technologies. And the challenge there is a bit different than what I normally tackle, because normally I try to talk to the wider public, but these articles are also targeted at chemists and industry innovators. So it's a bit of a different audience. So the biggest challenge is finding good reviews about the technology and finding good reports that you can use as a base to get information and get a starting point. And to be honest, one of the biggest problems is that when you look for reviews of a technology, you very often end up with reviews and publications authored by the same people that have submitted the nomination. So it's very complicated to really discern whether that's a really good technology, or is it something that, of course, like the authors talk wonders of because it's their own field. So in 2019, I approached independent experts to talk about the technologies. Sometimes I talk to the actual experts in IUPAC selecting the technologies, and sometimes you actually need to go to SciFinder or something like that and find other reviews that are not authored by the same people to try to see if it really has some potential. And then also because we're trying to find things that are in the sort of amid discovery and technological deployment, it's sometimes complicated to find actual news of factories and spin-outs and startups that are doing this commercially, because all of that is often IP protected or it's very secretive or whatever. So unless it's actually already commercial, it's hard to judge the actual potential, really. But it's a really fun job, actually. So I think like every year I set myself like a target. I'm going to do like 300, 400 words on each of the technologies, and I always end up writing more because you end up finding so much exciting information. But it's very interesting to see what's happening, and I'm really looking forward to doing the research on the 2023 technologies and finding new ideas about that. And it's always good when you see like the Nobel ceremony in October, and then you see something related to one of the technologies. It's good to see that, you know, you kind of IUPAC was right picking the technologies.
It's a kind of rewarding, right?
Oh yeah, it's very good. Rewarding, yeah.
The next question is related to science communication and how to become an effective science communicator. What are the skills that one should have?
Well, I'm gonna be mean and refer you to. There's another talk about this that I did, but I mean, there's many different skills that apply in science communication. But first, you of course need to like say that there's different fields of science communication. So it's not the same to be a very good science communicator in book form than to be a good science communicator in podcasts or in webinars or in person or in TikTok. So the skills are somehow transferable in some of the parts, but not at all the same. So, but in general, I would say that you really need to understand the science, and that could come from like a background in science, or from like a very good willingness to read papers, analyze them, talk to the researchers, and understand what's happened and what's been done with like a very critical approach and a very critical spirit. And at the same time, you really need to be humble and really need to go kind of get down and then be able to explain what you found out and find stories that connect with the people. Like in that sense, I mean, I don't know. I mean, I was just putting some things away before we started the webinar, but like, for example, like this book by an author called Sabrina Imbler from the States. It's amazing because it basically, the book talks about science of sea creatures and fishes and octopuses and whatever, but it does it in a way that it explains the situation about the animal, and then somehow, like in a second, it starts talking about personal stories that the author has experienced in school, growing up as a teenager, and it's really interesting because like you can really connect with the stories about the author, and then somehow relate that, oh, that's the exact same behavior of the, and it's a very, very touching and a very, very nice way of doing storytelling. So I think that's the key. Like if you want to do good science communication, you always need to be a good storyteller. It's less about the flashy presentations or the videos or whatever. You actually need to find the good stories and connect with the people. And I think, yeah, that there's a big challenge there with the top 10 because it's sometimes complicated to find success stories before the technology has become trendy. So it's hard to talk about RNA vaccines before they have solved the COVID pandemic. So it's complicated to do that, but it's always interesting to find a way to talk about that.
Yes. Yeah, it's difficult when the public doesn't know the application, right, of particular research. It's difficult to explain why are we doing this research. And me as a fundamental scientist, once I tried to communicate science with the general public, and I really found it difficult to tell a story that convinced people, because I don't have an application to my work, right?
It's sometimes, again, it's about the personal stories. You don't need to, I mean, eventually you do work and you do work as everybody else, and then your research is gonna have some sort of maybe we need to stop focusing on the applications, but then also like the process and what it involves and what you eventually can do. Again, when sorry to go to the same example, but probably when Katalin Karikó was doing the first experiments with mRNA vaccines, it was fundamental science, and it wasn't even envisioned as, okay, there's going to be vaccines that save the world from a pandemic or from pancreatic cancer, as it was announced a couple of weeks ago. But it was all about, I'm trying to do these vaccines, I'm trying to see if RNA can do this message or whatever. So you actually need to find something that people can relate to, and you need to find something that is again, that has something in common with the person you're talking to. So if the person you're talking to has just had COVID, the story about COVID vaccines could be very interesting. If they don't care about that, you may need to find something else. You may need to find a story about vaccines and cancer. You may need to find a story about vaccines and the kid. And then sometimes it could be a story completely unrelated. It could be something about, again, an octopus that is afraid of the other animals, and it could, you know, help you explain whatever story on like how fear works or whatever. So it's there's many good examples out there on how to connect. But I would say that for those of you who do more fundamental work, especially never give up at the beginning, because we tend to be like, it's very fundamental, it's very complicated, you wouldn't understand, like, and we cut and we never explain. But there's things that you do, like, oh, we have to read a lot, and people be like, oh, what do you read? Oh, we read this articles where people share like what they do, and then we follow a recipe. It's like a kitchen. So like all these sort of things like people would eventually relate to. And it didn't work. It's like, oh, like a recipe, because they never work. You can get a recipe from TikTok, you do it at home, and then you burn your oven. So it's the same thing. It's like you need to actually relate and find things that are that you have in common with that person and try to establish a conversation. And it's not only important for your work of science communication, but for communication as a whole. You cannot talk about politics, about music, about anything without finding some sort of common ground with the person you're talking to, because otherwise, yeah, it's very complicated.
Yes, because the main goal of science communication is to build trust in science. And the next question is, what drives the public trust?
Oh, that's it. That's very complicated. I don't know if it's, I mean, honestly, like I don't think that there was a very interesting science editorial published the other day. It's not that much about building trust. I mean, of course, but I think we also need to convey the idea that science isn't about trust and about faith. Like if science done it, then it's great. We need to convey the idea that scientists work and they do, they do reactions. Sometimes they work, sometimes they don't. They do vaccines, sometimes they work, sometimes they don't. And that we're humans doing a job, and the same way that you can be, I don't know, TV presenter and sometimes be caught on camera dancing because like the video it didn't go in and then you did a mistake. It's the same for scientists. So we need to convey the idea that about the process of science and how it works and how it's supposed to fix itself, like peer review and testing hypotheses and all this. It's designed to avoid mistakes in the long run, but of course there's going to be people that publish fake results. There's going to be people that I don't know, make mistakes and then suddenly give you a vaccine that doesn't work, or they give you a drug that causes problems like thalidomide. And we need to understand the process more than automatically trust. I think already scientists are very trusted by the public. If you look at all the public perceptions polls I mean, I've seen the ones in Spain and the UK and the US, and scientists always come at the very top, especially after the pandemic. So I think we're trusted, but we need to actually become a little bit less trusted and become a little bit more human. Again, I don't know if I'm allowed, like how I can share links, but if you go to Science, it was, I think, the editorial from a couple of weeks ago. And it was a very interesting reflection on how we need to communicate science in a way that reflects the process more than the results. And yeah, chemistry is going to solve climate change. Yeah, maybe, but not tomorrow. So we need to talk about the process and the materials that are going to make it possible and all these kind of things.
But we should give the idea that it's a process and it involves research, so we cannot give absolute answer. Yeah, and science is constantly changing, so we need to give this idea to the general public. But the next question is, do you ever read or watch other science communicators' explanation and feel like you can't cover the topics as they have done it already?
I mean, of course, like, do you mean like you cannot repeat the same thing, or like what do you mean exactly?
Well, this is a question from another person, so
Okay. So could you reread the question? Maybe I get it.
Do you ever read or watch other science communication explanations and feel like you can cover the topics as they have done it already?
I mean, there's many different angles on covering science communication. I mean, I don't think that any of the stories in this book is, I mean, actually original. They had all been covered in articles in the New York Times or like Scientific American or like Wired and many magazines. But the way this article covers it is completely original. This book covers them. It's completely original. So that's the thing. It's like there's always a new way to tell stories, and there's always a new way to. I mean, obviously there's a limit of like the times you can tell a story. Like, I mean, probably but even I mean, even when I say that, I was thinking like Marie Curie's story has been told so many different ways that you cannot do it again and again. And actually, there's a very good book. I don't know if it's been translated by a Spanish writer called Rosa Montero, who did a narrative book which kind of has pieces of history and pieces of what Marie Curie's life was, but it's actually the story of heartbreak and how she had to cope with losing her husband because he was killed by car or something like that. And then coping with that, all the science exposure, and 2 kids in the middle of Paris, being a woman in the start of the 20th century. And that's a completely different angle to every story about Marie Curie that had been told, because it focuses on her personal reflections and her suffering and her grief, and not on like the isolation of polonium or whatever science thing she was doing at the time. So I think there's always new angles and there's always new ideas. And of course, if you're reporting news for a chemistry news magazine like Chemistry World or CNN, if someone's covered it already, there's probably very little point on you covering it again. But there's so many different formats and so many different spins on a story and so many different ideas that I would say, yeah, by all means, try to do it again and try to find a new angle. That's always good. And that's part of what I was saying at the end of the presentation when I said the role of IYCN could be disseminating the news on and spreading the word on the top 10. I've done a feature article which is very technical and very dedicated to like chemists and innovators and industry innovators and maybe policymakers. That's why we did the Nature Chemistry and the Angevante, to try to broaden the scope. But that again is also very academic centered. If you want to broaden the scope, please use all the information that is publicly available, all the references, all the articles, rewrite them in different languages, talk about that in like a Twitter thread, try to talk about the top 10 technologies and like a series of TikTok videos. I don't really know. Like do what like it can be redone, and it's actually good if it gets redone, because then it gets more exposure and it gets more interest and people talk about it. And I think there's actually some very interesting studies in some of the technologies. Like for example, we talked about sustainable ammonia, and there's so many good things to say about how we make ammonia and so many cool stories there, including like the history of Fritz Haber. It's really interesting to talk about all these things. So just try to get different angles. There's always a new angle to tell a story.
We need to be creative, and as a science we need to be creative and then use this creativity to communicate the science, and there are many different ways to do it. I fully agree. Let me see if there are more questions. How does science communication help science?
Well, again, this could probably be a topic for another presentation, because I've got like I think actually like one of the first like IYCN pandemic talks, which is on YouTube, we talked about this. So if you go and Google that, you can find more info. But it helps in so many ways. First off, you can see so it helps the scientist, because like if you do communication on your work, and when I say you do, I mean anybody around you. It doesn't have to be you personally. It could be your press office. It could be a company like mine. It could be a journalist talking about your research. If you do science communication about your work, you'll get noticed, you'll get highly cited, you'll get more industrial collaborations, and all of this has been backed by studies that prove with numbers and figures that this is true. So that's one person that it helps the scientists to get noticed and get more funding and get more collaboration and get more citations. If you care about any of that, like getting the money, getting the citations, it really helps. It also helps your institution and the people doing science, because eventually again you get more funding and more visibility. But especially it helps the public get a wider education in science, because like you talk about science more often, and you can see that in the numbers and the figures as well. If you look into the COVID pandemic, nobody before the COVID pandemic knew whatever a coronavirus was, even though we were getting one every year with a million of colds and different diseases, and now everybody talks about coronaviruses. Nobody knew what a vaccine was and how it worked, and now everybody knows like 4 different types of vaccines. So you actually help doing more science education and getting a little bit there. And then also, if you look at the sort of policy making and things like that, it also helps that, because you actually influence politicians in a way that they care more about science. If they don't hear about it, they won't care about it, and if people doesn't hear about science, they won't vote political parties that care about science. So if there's more science communication, eventually affects the politics, and that eventually affects the funding and affects. So there's a whole set of benefits of doing science communication. Apart from the fact that it's so much fun, like I really enjoy talking about science, and you know, in a variety of formats, like writing narrative, writing news stories, writing Twitter threads, doing presentations. But again, if you don't like it, it's fine. Like there's other people that do it professionally. Like you can also not like writing grants, and there's people that write grants. You may not like editing journals. That's why there's editors. So just if you don't want to do science communication, it's fine. But I think for you as a scientist and your group and your institution, it may be good if you found a way of doing that science communication, even if it's not you personally, maybe finding someone else who can do it. That can really help, and I can really help get your research a bit more noticed. It's really interesting.
I think there are tasks for everyone, right? So for every business. Yeah. So we have another question from the audience. Someone says, great talk, Fernando, as usual, and great to see you doing all of these IUPAC and supporting IYCN. Since the IUPAC Top 10 Emerging Technologies is an initiative that started in 2019, I was wondering whether you have any data or info on indicating the use of the early release technologies by the industry over the years for the benefit of society. Of course, not considering the chemical synthesis of RNA technology. I'm referring to some kind of follow-up on the impact of the great work you, Javier, and IUPAC as a whole have been doing here. Thanks. From João Borges.
Hi, João. Well, first, thanks for helping organize this, and I'm sure that you had some something to do with suggesting my name, and I'm very grateful for that. And I'm always happy to collaborate with IUPAC and IYCN. And then, no, and that is a very good idea. I mean, beyond the very few examples that I've highlighted during the presentation of like technologies that have then received the Nobel Prize, which is all, I mean, obviously a little bit tricky and probably biased, because of course if you do an article about Caroline Bertozzi, like I did like 4 years ago in a magazine in Spain, of course she's going to win the Nobel Prize at some point, so then you can go and be like, I did this article. So that's a little bit of what happened with like an anti-selective organocatalysis and other technologies. And I haven't looked at the commercial implementation of any of the technologies after they have been selected. I do look at the implementation when I'm writing the article, and if there's any startups and things like that. Like I remember we had sodium batteries last year, and there was a couple of big Asian companies, I think in China and India, putting a lot of energy, sorry, pun not intended, putting a lot of energy and resources into developing big sodium batteries, but I haven't followed up. That could be more of a sort of innovation, technology transfer expert sort of work. I'm thinking like reviewing like McKinsey reports and Deloitte reports and things like that to see if there's market value. And they have been, but I think it's a very, very good idea. So we haven't done it from IUPAC, but it could be something that gets tackled in the future, either from the IUPAC Top 10 team or in collaboration with other people. So if you want to, I don't know, suggest that to Javier or Ehud or Fabien or anybody in the team. Again, like I said at the beginning, I only write the features about this and sometimes help with the social media. And some of the presentations, I'm not behind the brains that organize all the initiatives in IUPAC and put the money in one thing or another. But that sounds like a very good follow-up. So it could be an interesting article, even like the Nature Chemistry and the Agata that I showed before. Kind of instead of analyzing the SDGs, analyzing the commercial uptake and the success of the technologies to see if it's actually a good tool to predict the future. That's a very good idea. So if, again, we discussed recently on Zoom about different ideas, so this could be another one that would add to the pile of potential collaborations in the future. We could talk later, or maybe talk in The Hague, or just drop an email to Javier, and we can start the conversation. I think it's very interesting.
We are now approaching our closing time, and I want to thank you very much, Dr. Gomollón-Bel, for your wonderful presentation.
Thanks, Elisa, and thank you again, Dr. Fernando Gomollón-Bel. Thank you so much for accepting to be our speaker. It was an excellent and insightful talk into the process behind it, and especially on science communication and your work. So thank you so much for joining us.
Thank you so much, everyone, for inviting me. And yeah, look forward to the next Science Café that you organize. I'll keep an eye on that. And yeah, thanks again. And yeah, have a very nice, I don't know where everybody is, so evening, morning, rest of your day. Thank you again for the invitation. It was a total pleasure. Thank you so much.
Thank you so much for joining us. So just a few more things in closing. I'd like to let all the audience know that we have done this series before, as covered by Dr. Gomollón-Bel. It is available for free on YouTube. If you just go to the link, either go to the IYCN channel, or you can follow this link, and you can see all the past science cafes that we have done, including this one that will be uploaded later. As we are members of the IYCN, and it is an international and diverse network, we have a commitment to equity, diversity, and inclusion. We as a network can only succeed if early career chemists from all nations have the opportunity to join, network, and participate. And it is a platform that is a constructive route for bridging international borders. I'd like to advertise the IYCN mentoring program for this year. Applications are open, so please apply before the 1st of June. This program is intended to support PhD students in their career development, and it aims to connect chemists from all over the world to support and prepare current PhD students in the chemical sciences to make informed career decisions. The duration is for 1 year, in which the mentor and mentee are expected to meet regularly, and the applications are open, so please apply as soon as possible. Thank you again to the audience and to our speaker for attending this Science Cafe. Please follow us on all social media or visit www.iycnglobal.com/events for future events. Thank you so much, and have a good evening or morning wherever you are.